Nobody? I would be happy to. Number 5. 1/4 x squared plus x minus 6. Tell me what you know before I graph it. It's going to open up. Skinny wide. Wide. Why? Because it's a fourth. It's less than 1. Y-intercept. -6. All right. Let's find the vertex first. Or actually, let's list out our A, B, and C. What's A? 1/4. This is too wide. What's B? 1. What's C? -6. So as I graph this, let's see. I'm going to do x equals opposite B, which is -1 over 2A. Oh, I see why y'all didn't like this one. -1 over 2 times a 4 is what? A half. And I never want to divide by a fraction. What do I do instead? You multiply by the reciprocal, which just means flip it over. So this is really -1 times 2 over 1, which is -2. So that means my axis of symmetry is at -2. How do I find where on this axis the vertex occurs? Plug it back in. Take that original equation, plug it back in. And let's see, -2 squared is +4, and 4 times a fourth is 1. -2 minus 6 would give me -7. Is that what y'all got? So on this axis, I'm going to go down 7, 1, 2, 3, 4, 5, 6, 7. What about the easy point? Should I use the y-intercept or nah? Yeah, definitely. I definitely would. That's less work. 1, 2, 3, 4, 5, 6. And then last step, reflect and connect. Mine's really wide. It shouldn't be that wide. I just kind of... Well, there you go. We're good? Anything else? Yes. I'd be happy to. Number 4. -4x squared plus 8. So this one's a little bit different because I'm missing what? The b in the middle, right? So here, a is what? B, what is b if it's missing? 0, and c is 8, right? And so I need to know, well, first tell me what it's doing. Down, skinny, what's the y-intercept? 8. All right, so I'm going to find that axis of symmetry first. Opposite b, which is just 0. And then it doesn't matter what's on the bottom because 0 divided by whatever is just going to give me 0. Which means that the axis of symmetry is the y-axis. I need to find you a sheet so that you have something to follow along with. All right, so now whenever I plug that back in to find where it falls, I get -4 times 0 squared plus 8, which is just 8. And why am I in a bit of a conundrum now? You're not saying it right, but you're right. I know what you mean. We can't use the y-intercept as our easy point now, right? Because the vertex is the y-intercept. So now I've got to find a new easy point. What did you guys use for your x? I would use 1. I'd probably use 1 just because, and if you use something like 2 or something else, that's fine too. I tend to stay really close to the vertex as close as I can, but you're not wrong either way. If I put 1 into the equation, I get -4 times 1 squared plus 8, which is -4 plus 8, which is 4. So 1 1, 2, 3, 4. And then I'm just going to do reflect and connect. Terrible. But what you think? Okay? Y'all got to speak up if not. Any other ones you need me to work? Ready to switch gears then? All right. Switch it up to your notes. Get a notebook. Try to make this as painless as possible, but we're going to do the last 2 versions today. And tomorrow we will probably just practice with all 3 versions. All right, I'm going to run through this as quickly as I can while still making sure you understand well enough. Just stop me if you need me to slow down. All right, so vertex form, this is probably my favorite form. It's the easiest to graph in. It's also the one that we go back to a lot. But vertex form, just like standard form, it has its own little way of graphing. It looks a little bit different. We could always, however, get back to standard form if we needed to. The way we would do that is, if you notice, you've got this x minus h squared here. I could write that twice and FOIL it out, and I could get myself back to standard form. Now, this one looks a little bit different, some new variables in here, but then one of the same variables. Notice that a that's in the front. The a still does the same thing it did before, okay? This is still telling me if I'm up or down, and it is also still telling me if I am skinny or wide. Now the new thing here is my H as well as my K. And since this is vertex form, the H and K are actually giving me the vertex. You know how we have to go through all that work to find the vertex in standard form, opposite b over 2a, plug it back in, and it's a lot? That's all eliminated in this form, because in this form, the point HK is my vertex. I just literally pull it out of the equation and I have the vertex. The only thing that's a little bit confusing here is this H is the opposite sign of whatever's in there, and the K is the same. Yeah. So let me show you a couple examples and then we'll jump into graphing. If you can graph in standard form, you can definitely graph in vertex form because it's a lot easier. I don't want to, are y'all still copying? Y'all good? Then while they copy all this, there's also, I told them on the first day, there's in Canvas, there's a link to the notes if you ever need them. There's a link to the recording where I teach it and everything. Everything you need is right there in Canvas. So if you ever need anything or need to go back, that's all there for you. So you can find a link to this too. Were you just added this morning? I think it resyncs every night. So it might be tonight before it syncs, but we'll check as soon as I finish. We'll check. All right. Tell me what you know so far. We know the vertex. We can definitely find the vertex. What is the vertex here? Look at y'all. -1, -2. See how easy that was? No opposite b over 2a. No plugging back in. I literally just pull it out of the equation. What else do you know? Look at that a. It's going down. Is it skinny or wide? How do you know? That's right. The absolute value of it is less than 1, so it's definitely wide. Y'all okay? Y'all ready to graph one? All right. Oh, this one's quick. The graphing is going to be the exact same steps that we did yesterday. The only difference is the steps that say find the vertex, you don't have to go through those because we can grab the vertex, right? So if I want to graph this one, say it again. Yep, this is the problem we're going to graph. What do you think I need to do first? Find the vertex. I'm always going to find my vertex. My vertex here would be what? 1, 0. Notice that K was missing, so I put a 0 in for it, and that's okay. My axis of symmetry still goes through the vertex, so here, 1, 0. Here's my vertex, and if I need the axis of symmetry, I can still draw that right there through the vertex. They might confuse. When we were in standard form, after we found the vertex, what was the next thing that we did? Did the easy point. So here, I do need to realize what an easy point is and how I find it. So if the vertex is 1, 0, what's a good easy point to use for x? Maybe 2? That's generally what I do. I usually go to the right one. You can go to the right or the left. It doesn't matter. So maybe some of you pick 0, some of you pick 2. And you could even go further. The further you go, the bigger your numbers are going to get, right? Because remember what that parabola does. It starts out going up slow, but then it goes up really, really fast. So maybe for my easy point, I choose 2. Same as before, I'm going to plug it in. Watch your order of operations, though, because when you plug in, remember I need to do parentheses first and then exponent. So 2 minus 1 is 1, and 1 squared is 1. So that point is 2, 1. 1, 2, and then up 1. And what do you think that last step's going to be? Reflect and connect. That's exactly right. Over 1, over 1. If you picked 0 and you plugged in, it should have still given you 1. There's my parabola. What do you think about vertex form? It's a lot faster, a lot easier. Once you get standard, that's why I usually spend a day. I used to do all 3 in one day, but if you spend a day on standard, it makes the others a little easier. Do we need to do another one, or are y'all okay? We're good. Vertex. All right, let's move on to intercept then. It's a little bit harder. This is probably the most beneficial form. It's the one we use the most to do analysis with, but it's probably, it's not as hard as standard form. Put some new variables in here for you. What's it mean to be an intercept? On a graph, what's an intercept? It goes through something, one of the axes, right? In this case, it's going to be the x-axis this time. We've been dealing a lot with the y-intercepts, right? And we pull those out in standard form. For this one, it's going to be the x-intercept. A, again, does the same thing. We're still talking up, down, and we're still talking skinny or wide. Here, just like the name suggests, it gives me the intercepts. Now, if I'm talking about x-intercepts, and think about this for just a second, picture that parabola in your head on the coordinate plane. How many x-intercepts should you have? 1 or 2 or none, right? But I could have up to 2 this time. How are you having up to 2? Well, think about it. How many times does it cross the x-axis? 2. How many times does it cross the x-axis? 1. How many times does that one cross the x-axis? None, right? But I can have up to 2. So for my ones that have 2 intercepts, intercept form is great because it's going to identify those 2 intercepts for me. The intercepts here are going to be x equals p and x equals q. These numbers that are in parentheses with the x, those are the places where it's going to cross the x-axis. Now again, because I'm telling you there's a minus here, these are the opposite signs. When we get a little bit further, you'll find, and you should have hit this in Algebra 1 also, this is actually the factored form. Y'all remember factoring quadratics in Algebra 1. If you don't, that's okay. I'm going to teach it to you like you have never seen it before. I'm going to assume you haven't and go from there, because some do and some don't. So, okay? Tell me what you know. Based on the A first, tell me what you know. It's 2. What does that tell you? It opens up, so I'm happy. What else? Kenny, because it's big, right? Where am I crossing the x-axis? Close. Change the sign. That's right. 1 and -3. Here's a rule of thumb. This is how I try to remember whenever I'm dealing with equations like this. If it's in parentheses, rule of thumb is it changes sign when we're dealing with quadratics. If you're looking for the x-intercept and it's in parentheses, we're changing the sign. If I'm in vertex form, the h is in parentheses, it changes sign. The k is not, it doesn't change sign. So in parentheses, it changes sign. That'll help you remember it. All right. So that means it's crossing. Now let me ask you this, because we're missing a crucial part. If we've got the x-intercept, so I've got this parabola, I know it opens up, I know I've got 1, 2, 3, and I know I've got 1. So I've got the reflected points. What am I missing though? I'm missing that vertex. I'm missing that right in the middle, that axis of symmetry in the middle, so I can find the vertex, right? So whereas the point that I've started with every single time, I'm missing that now. So now I've got to find that. So I'm kind of going backwards. So this one starts at the end and works our way up. Okay, so now we got to find the vertex last, and I'm going to show you how to do that. Now, if these are the intercepts, the vertex lies on the axis of symmetry, and if these were reflected, where does that mean the axis of symmetry is? Right in the middle, right? -1, which is -1. But what if it was a little bit harder? What if these weren't nice even numbers where it just fell, I could just look and find the middle? How do you find the middle of 2 numbers? Average them together. You're exactly right. We add them together, divide by 2. So to find in the middle, and I'm going to go back to this general form right here. To find exactly in the middle, to find the axis of symmetry, I'm sorry if y'all like the notes all nice and neat and I'm jumping all over the place. I'm going to find the middle of them. I'm going to do both x-intercepts, and I'm going to divide by 2. That will give me the middle. Does that make sense? Opposite signs, though, because I graphed them with opposite signs, so I need to add them with opposite signs. So let's go back to this one and see if that works. If I wanted to know, what's wrong? Oh, I'm sorry. If I want to know the axis of symmetry here, right, I should be able to add these two numbers together and divide by 2. So if I do axis of symmetry, 1 plus -3 divided by 2, what do you get? -2 over 2, which is -1. Is that the middle? Yep. Now let me ask you this. If you have the axis of symmetry and you need to know where on the axis of symmetry you go to put the vertex, what do you do? Think, plug it in. We're back to where we were in standard form. We just plug it in, right? So if I know x equals -1, well, then I can just plug that back in way up here to find the y that goes with it. Does that make sense? See how everything's kind of looping around to do the same thing we've been doing? So if I plug -1 in that equation, I end up with 2, -1 minus 1, -1 plus 3. Which is -8. We'll pretend like that's going down to -8. What do you think about the last two forms? They're definitely easier than standard, right? At least they give you something to work with. Standard gave us nothing. What's the form? Not sure. Vertex form. How do you know it's vertex form? Parentheses with the exponent out there, right? So this one's vertex form. Vertex form gives me the vertex, which would be what's the form? Standard form this time, which gives me nothing other than the y-intercept. What's the form? Intercept form. What are the intercepts? What's the axis of symmetry? Well, 3 over 2, 1.5, yeah. Add them together and divide by 2. 1.5. How would I find the y that goes with it? Plug it back in. Yes or no? What do you think? All right, I'm going to stop.